Okay, this says, what is the intensity in watts per meter squared of 85 decibel sound? All right, so our equation that we have for this one is, we have this beta symbol, which is in decibels, is equal to 10 times the log of the intensity over the initial intensity. So that the decibels that it's giving us is 85 is equal to 10 times the log of, we don't know what the intensity is. That's what we're actually trying to find. And that initial intensity is 1 times 10 to the negative 12th watts per meter squared. Okay, so now we got to actually solve for this. So first, what we're going to do is we're going to divide by 10. So that 85 divided by 10. So 8.5. And then you're going to need to do basically the inverse or divide by log, which if you look on your calculator, if you have a log button, if you do second log, it's like 10 to the, okay? So you're going to end up with this number right here, because see how it's in the denominator? So it's going to be like 1 times 10 to the negative 12th watts per meter squared. Sorry, my mom keeps texting me. Times 10 to the 8.5. Okay, and then that's going to end up being 3.16 times 10 to the negative 4th watts per meter squared. Okay, so hopefully I didn't confuse you too much. Just remember, you have to take this one and multiply it over to the other side, but you have to do the inverse of log, which is this 10 to the 85 divided by 10. Okay, so, all right, now we're into the Doppler effect, yeah. So this is saying what frequency is received by a person watching an oncoming ambulance moving at 110 kilometers per hour and emitting a steady 800 hertz sound from its siren. The speed of sound on this day is 345 meters per second. For some reason, they gave you that the ambulance was moving at 110 kilometers per hour. So it is possible that you would have to convert that. So if you did convert that, then you would get 30.56 meters per second. That's sort of the first step. Okay, so now this is saying received by the person that's watching, so the observer. So the frequency of the observer is equal to the frequency of the source times the wave velocity divided by the wave velocity plus or minus the velocity of the source. Okay, so the frequency that it gave us of the source was 800 hertz times the wave velocity, or the speed of sound in this case, is 345 meters per second divided by this 345 meters per second. And when it is talking about the oncoming or approaching, then it's this minus, okay, minus whatever that speed of the ambulance is moving, the velocity of the source itself, which we figured to be 30.56 meters per second. So if you solve that, you should get 878 hertz. Okay, and this says, what frequency does she receive after the ambulance has passed? So this, in this case, you still have your 800 hertz, okay? And it's still going 345 meters per second. But now, since it's receding or going away from the observer, now you actually add that speed of the ambulance, and that ends up giving it or making it 735 hertz. And just kind of think about it. Like when something's coming towards you, it sounds so loud. And when something's like going away, it starts to sound a little, less. Okay. Now we are into the overtone section of it. We're almost done. We've only got 2 more. So this says, what are the first 3 overtones of a bassoon? Is that how we say that? I'm guessing. That has a fundamental frequency of 90 hertz. Okay, so first off, it says fundamental. So if you watch those videos, the fundamental meant that was 1/2 basically. And so it kind of has this basic equation right here. It was like N times the velocity over 2 times the length. Okay. And as far as the N is concerned, for the fundamental, it's just the, hold on a second. I have to